Hello and welcome back to another session of Effective JaRu, the series where we will read effective Java and see how the items presented here will translate to idiomatic Rust and what it means basically. So in this chapter here, chapter 4, it's all about classes and interfaces, and it basically tells you one thing in many different ways: minimize the accessibility of classes and members, because the less can happen to them, the more immutable they are, the better, right? The better you control the mutability of your data, the safer you are. And guess what? Rust does this absolutely natively, and this leads to some interesting things when you compare this to Java, for instance. So this is really just that. The first item here just tells you about the ways to do your stuff. Private is the default. Private and immutable is the default for everything you do in Rust. So that's quite interesting. Actually, it's not exactly true, because things are by default package private, right? So when it comes to accessibility, then in Rust everything is package private. Let's just see how this works here. So let's use the time thing, for instance. Oh no, let's use point for now. So struct point, and we have x, which shall be a double, which is an F64. Who would have guessed that? Isn't that nice? You know, you don't have to know that a double is a floating point with double precision, which means it's twice 32-bit. No, just F64. So this is by default package private. Package private means that I am able from any function in here to access the private fields of my point. And it doesn't have to be something on point. It can, I think, be anything. So if you do a test here, then within this particular package here or module, I am able to access the point. Access private point fields. And there we go. So let's have a point P. Let's make it mutable even. X shall be 1 and Y shall be 2. And yeah, this is something I already couldn't do in an integration test, for instance, which pulls in the point as something that comes from as a client, basically, right? This is right now I am part of the package, so I can do this kind of access. So let's see if that actually works. And yeah, maybe I also wanna do some assertion here. Px is supposed to be 1.1.0. So here's my access, and that should already be at cargo test lib. And it works, even though under these circumstances, indeed, there is no mutability required here. And that is that. But from the outside, that is not possible. So let's make an integration test. Access.rs. Let's pull it in. Item 14. Use item 14 point. And that's already where it starts, right? Because point is not even public. So everything is package private, and the fields are package private as well. So that's something you could say in Rust compared to Java. That's just the default. There's no private. There is no way to prevent anything in the module here to access the point's members. But here, that's already clear. So if I would try to, let's try to run it or to execute it. Cargo tests, test access. So that's true. So as you can see, struct point is private, and can thus not be imported. So in order to get that to work, we have to make it public. And now if I wanted to have a p here similar to this, you see that it will not work just because it's private. Of course, privacy in Rust is package private if you wanted to translate this to Java. And the book tells you that you should not do that, what you see here. I mean, you should, actually this is what you should do, right? Accessors and mutators, so you put everything through a function by default in order to have control over it, right? And because every function call you get is a place where you can basically do things that are different or that change over time. Whereas if you allow access to fields directly, mutably or even immutably, you are kind of set to that particular API, and you cannot ever change it again after your library went 1.0. You know, and this is always something you want to think about. Personally, in case of these types here, where the fields have a domain which is exactly the size of their field types, basically they're totally unrestricted in domain, then each value that they can have is totally valid. And mutability is not a problem at all, because Rust will take care of assuring that no race conditions happen ever, right? So in Rust, in this case, I see no need to go overboard and have accesses for this. So this would be an idiomatic Rust implementation, if you ask me. So now that all this stuff is public, I should be able to use it as before. Nice. And yeah, this is something interesting. It just happens to be like that because Rust is Rust, and Rust works a bit differently there, but you can be sure that nothing bad can happen from this. So I don't know. This is something I just wouldn't do. So time is a bit different because time has a very limited domain, right? We have two fields here which may not exceed certain values. So the value domain is 0 to 24, 0 to 23 actually. No, 0 to 24. 4 hours per day, and 0 to 60 for minutes per hour. And I wonder if you now have 25 hours and 61 minutes, 61 possible values, but probably not. Probably I'm just getting it wrong or having the wrong thought model here. So yeah, making these fields pub would be, I mean, let's start out like this. So they have public final int hour, public final minute. So they have constant fields, right? They cannot be changed after an instantiation, which means they cannot be reassigned primarily. This is all that final does. Reassignment is impossible. However, in Rust, you cannot do that. You either keep these fields private or you make them public and indeed lose all control over it. So in public, in Rust, this would basically mean that pub is not an option here, never. So we would use an hour here, which is, I think U16 shall suffice. Actually, U8 should suffice for the hour. And for the minute, there's also a U8. And we are good. I don't know why he uses ints here for storage. This is quite, I mean, you could say it's an example. Let's keep it simple, int everything. But it makes no sense. Sure, you don't have unsigned values in or unsigned primitives in Java, but there should be a way to use, you should use shorts here, couldn't you? Or you could use, I know what that is, a byte here, because bytes with 128 values in each direction, signed and unsigned, negative and positive, would be sufficient here as well. Anyway, we would do it like this, I think. And then, of course, we need a constructor, new, I call it new checked again, usually you would, because new is usually expected to return a new instance no matter what. And new checked for me is something that returns a result. So we have an hour, which is a U8. We have a minute, which is a U8, and we shall return a result with the time in the OK slot and some sort of error in the non-OK slot. I think we can provide a boxed error here and use a string, which will then automatically be converted for us. If we want that, of course, we have to use std error. We could also just use, yeah, let's do this. Let's try it. Std error. So we don't have an own error type. We just provide something that fits the error interface. And we box it because we don't, you know, the caller doesn't know the size of this thing. We just want to provide the interface of an error, but instead of implementing our own, we just throw a string in there which can convert itself. Which hopefully can convert itself into an error. I will see if that works. So new check, let's see. So if hour is larger than 24, larger or equal, I wasn't seeing that, damn it. So that's all right. Larger or equal 24, then return error format, so that will return a nice string that we can then hopefully convert automatically into an error. I will see. So must not exceed 24, and then we can throw in the hour. And as you can see, this is checked at compile time. At compile time, it verifies that the format is ready, which also means that this must be a string literal, right? So we can't use this macro, at least in the moment there is a generated format string like that. So if minute is larger or equal 60, so why am I using magic values here and then repeat them here? Well, it's really not going to change. It's time and hour per day. It's hour and minute per day, and this is, yeah, I think going to stay for a while. Format that again, so far it doesn't light up red, and I trust my linter far enough to know that it should be fine to that point at least, but we'll see about that. Oh yeah, sure. Now it's not fine because I should throw in the minute here. And last but not least, we return a new time with hour being the hour and minute being the minute. And if you should provide accessors, you know, to change that thing, we can. I mean, right now you can't even query the values, so probably you want to do at least, oh yeah, that must be public as well, not to forget. pubfn hour shall return a U8, which is our hour, and pubfn minute should return a U8, which is self minute. And this is something that should work from the outside, that verifies our invariance, and that will basically prevent any other change to the hour and minute. If you wanted to allow that, we could without any problem. We would just have to implement the respective setters and make sure some error handling is done there. So let's see how that works. No. So unfortunately, this is not implemented. Oh yeah, sure. And at the very last, you want to wrap this into an OK. So now the only problem that we have is that we cannot convert a string into an error. Let's see, maybe there's some cool way to do it. I think there must be one. I'm certain I'm missing something here. But the error trait is indeed not pre-implemented for anything? Well, under these circumstances, I guess we can just say we provide an error string for you and you can deal with that yourself. This doesn't have any real disadvantage, except that, of course, you have to convert the string yourself into your own kind of error if you like, or you just print it, obviously. Oh yeah, then we don't need error anymore. And that is that. We could test the time so far and, well, assert equal. Yeah, actually I don't want to do an equality assertion, but this one would be good. We could test the error cases, use point and time, and say, well, time new checked, 25 and 20 is error. That must be an error. So now 23 and 61 is an error for different reasons. Let's make this 1. But this one is okay. That one will be fine. Yeah, actually I can just do it like this. I unwrap on the value here. This will panic anyway if something is wrong unexpectedly, and the test will fail, obviously. And then I can basically just verify that my accesses are working. So hour should be 4 and minute should be 20. And that's already quite a full test for the time here. And yeah, there's no doubt about the usefulness of this interface, because we had no other choice, right? I didn't see another choice. And interestingly, with all the complexity that you have with class inheritance and the way fields work and no real constants, and whoa, I think it's easier to get stuff wrong here in Java. So that is that. So in item 15, we have a complex type, which basically shows an immutable type, which does not provide any mutating functions, right? And again, in Rust, I wouldn't really mind providing mutators because you can only call them in the right circumstances anyway, you know? And if you keep these things around, or these types or these instances around in a non-constant or in a shared environment, then you can only call methods which do not mutate anyway. This is the same in C++, right, where you can basically control that, even though it's more safe because you cannot accidentally provide write access to something that only needs read access. So that is that. But long story short, it's a kind of functional programming style, so you will never mutate the state of something that has been created. So you always create new states here, which is more costly at points, but has the usefulness that you have a shareable state all the time, which is what kind of Rust provides to you automatically. There's no real, there's no benefit in doing this, really, which is really, really interesting. Item 14 and 15. Yeah, the next one, I think the next one I will just put into the next session. So thanks for watching and have a great day.